I'm Steffi from the PantaRei Group. We are the agent and partner for PantaRei in Indonesia, and it's a pleasure to be hosting this webinar today. I also have some of our colleagues with us online who will be happy to assist with any questions you may have specifically regarding the Indonesian market, either in English or Bahasa. So today's webinar is part of the ZDHC 2024 Roadshow, and we're delighted to have participants from Indonesia and Pakistan, as well as other countries, as we can see. We trust that the content today will be interesting and insightful for you. And our speakers for this sessions are Mr. Saket Kulkarni, who is the implementation manager for ZDHC South Asia, and Mr. Manuel Romero, the project engineer at PantaRei. As for the agenda, Mr. Saket will kickstart our session with an informative overview of the ZDHC Roadmap to Zero program. Then Mr. Manuel will present the various wastewater treatment and recovery systems designed to ensure compliance with ZDHC guidelines. He will also share case studies specifically for root cause analysis and corrective action plan. Throughout the webinar, we highly encourage your participation. We will have Q&A sessions after each segment, as well as at the very end of the webinar. So please feel free to use the chat box and share your questions there. So let's get started. Enjoy the webinar, and I will hand it over to Mr. Saket.
Thank you, Steffi, for organizing this session. I will share my screen. Okay, my screen is visible?
Yes, we can see your screen, Saket.
Yeah, okay. So once again, thank you, Steffi, and thank you, Manuel, for organizing this session. This is the part of our activity, as we call it, as a InConnect roadshow with our solution providers. So today I will give you in a very brief what is the ZDHC Roadmap to Zero program. Might be possible some of you are already implementing this program, but in a very holistic way, in a very brief way, I will try to give you an overview about the ZDHC. So ZDHC, as you know, it stands for Zero Discharge of Hazardous Chemicals. It is a non-for-profit organization established in the year 2015 as a joint roadmap initiated by 6 brands, and in 2018 we established another entity called as an implementation hub. So basically what ZDHC is doing, we are developing the guidelines for the textile, leather, apparel and footwear industries. So we are working in these 4 industries, and ZDHC Foundation is mainly developing these guidelines, and all these guidelines are implemented by using some platforms, and these platforms will be through, and all these activities for the platforms, for the implementation, we are doing through our implementation hub entity. So what is ZDHC and what ZDHC is not? Before starting our any presentation, we always try to give you this narrative. Okay, what is ZDHC is all about? So basically, it is a holistic approach for the sustainable chemical management into 3 focus areas, that is input, process and output. These are the 3 focus areas. Our philosophy is very simple. If you have clean input, then you will get clean output. Now clean input means if a factory, if they are purchasing the safer chemicals, safer materials, then their output in terms of the water, in terms of the wastewater, in terms of the air emission, in terms of the sludge, or even in terms of the product, it will be free from harmful substances. And the focus is always remain onto the consumer and worker safety, as well as the environmental protection in the textile and leather manufacturing facility. What ZDHC is not, so basically, as I mentioned, it is a holistic approach for the sustainable chemical management. It is a program. It is not a certification, but it is a set of continuous actions into the wet processing facilities. So that means whichever facility is using the dyes and chemicals or the performing the wet processing applications, in all those facilities, the ZDHC program will be implemented. And it is the terminologies like ZLD, zero liquid discharge, and ZDHC quite be similar when we hear these terminologies. But ZDHC is not only about ZLD. Definitely, you can achieve by using some of the wastewater methodologies which Manuel is today speaking about. But it is not only about the wastewater treatment methodology. It is the holistic approach from the input chemical management, from the process part, and from the output part as well. And lastly, it is not distinct from any other chemical management certifications or approaches as well. That means if you are already implementing some of other schemas in the chemical management space, then ultimately you are supporting for implementing ZTHC program as well. So I will give you an idea for a supplier, what will be the supplier journey for implementing the ZDHC program. So these are the some of the stages through which supplier should undergo for implementing the ZDHC program, like starting with registering into the gateway account, prepare a chemical inventory list, request ChemCheck report or ChemCheck summary report from the chemical manufacturer, or check each and every chemical whether it is published into the gateway platform or not, generate monthly performance in check reports, then conduct verified in check level 1, then establish a connection request with the ZDHC signatory brands. Also, perform the supplier to zero assessments at level 1 and level 2. And lastly, perform the wastewater testing and generate clear stream report. In case of any failures, perform root cause analysis and corrective action plan as well. So basically, these are the different actions for implementing the ZDHC Roadmap to Zero program. So this is the simple CI template which is available onto our website as well. You can download it and you can fill all the details. So whatever incoming chemicals you are using into your facility, you should mention all the details of such chemicals and check whether those products are registered into gateway or not. The second thing is about the gateway platform. I hope all of you are registered into the gateway platform, but if not, then you can register into this platform. So in this, there are two modules. One is the chemical module, another one is the wastewater module. So chemical module is basically the world's largest database of safer chemicals. As of now, there are more than 110,000 chemical products which are ZDHC MRSL compliant products are registered into the gateway. And wastewater module is about it is also an online platform to register and share your verified wastewater test data against ZDHC wastewater guidelines. In my earlier slide, I mentioned about a terminology as a ChemCheck. Like for example, ChemCheck means a product passport. For whatever chemical products you are purchasing, you can ask the ChemCheck report, which ensures you that this product is ZDHC MRSL compliant and does not contain any harmful chemical, and it is published onto gateway platform. So whichever products are published onto gateway platform, for all those products, the chemical manufacturer can generate a ChemCheck report and they can share it with you. The most important part is about the input chemical management. So in the input chemical management, we have a guideline called as a ZDHC MRSL. MRSL stands for Manufacturing Restricted Substances List, which is a list of substances banned from intentional use in commercial chemical formulations. That means whichever chemical you are purchasing and using in your factory. So in all those commercial chemical formulations, the MRSL listed substance should not be present. Why these substances are regulated? Because these are harmful for the health, environment, and aquatic life. As a supplier, as a textile or leather manufacturer, it is your responsibility that you should purchase at least the DHC MRSL conformant chemicals. And these chemicals are divided into three levels: level 1, level 2, and level 3. So at least as a supplier, you should purchase level 1 compliant chemical products. When you prepare your chemical inventory by using the gateway platform, you can also find out whether that product is published into gateway or not. You can just simply the product name. If I request all of you to please mute yourself, and if you have any question, then after my session you can ask the questions. You can also check whether whatever products you are using, so such products are published into the gateway platform or not. You need to just put the product name and see if you get the similar kind of results or not. The second step is about generating in-check report. The first stage is preparing your CIL, request check report from the chemical manufacturers, also check onto the gateway platform whether the product is published or not. Second stage is generating the in-check report. Now, in-check report is basically a report which gives you an idea. Okay, what percentage of chemical products are ZDHC MRSL confirmed? That means in your facility, if you are using 50 chemicals, and out of that, if 25 chemicals are MRSL confirmed, then it will create a baseline for you that 50% of your chemical inventory is MRSL confirmed. And this baseline will give you an idea, okay, how you proceed further, how you improve yourself in terms of your input chemical management. And for generating these in-check reports, you need to subscribe any of these 5-6 platforms. And once you subscribe, you can generate your monthly in-check reports. So this is how the in-check report looks like. Every month you need to upload your monthly chemical inventory, and then it will give you an idea total number of products, and out of which how many products are MRSL confirmant at level 1, 2, and 3, and how many percentage of products are non-confirmant. And for those non-confirmant products, you can connect with the chemical manufacturers and you can request them for publishing the products into the gateway platform. And this is how you can improve your MRSL confirmance status as well. The third stage is about the verified in-check level 1. Now the performance in-check report, what happens? The inventory is uploaded by yourself. So that is why there is the issue of credibility and transparency on the inventory. To create the credibility and transparency for the inventory, we have come up with a new guidelines called as a verified in-check level 1. So basically it is a spot check guideline where the supplier undergo a verification, and if they achieve more than 80% of score, then they will get a check mark. It looks like this. This is how the check mark looks like. So the entire exercise will complete within 2 hours or 3 hours, and it will be conducted either by second party verifiers or third party verifiers. Second party verifiers means even the ZTHC signatory brand representatives, they can also perform these verification at their supplier facility. Then the fourth and most important step is to establish a connection functionality or connection request with your ZDHC signatory brand. So when you establish a connection request with your brands, that means you are giving them access for the data. So whatever you are doing onto the gateway platform, whatever you are implementing for the ZDHC Roadmap to Zero program, so you are sharing this data with your connected brand. So for example, your in-check reports. So brand can access your in-check report. Brands can access your ClearStream report as well. And this is how the transparency is built between a supplier and a brand. So brands can also send a connection request to you. Otherwise, it will work otherwise around as well. You can also send a connection request to brand and establish a connection request. So this was all about the input chemical management. In the process part, we have a platform called as a Supplier to Zero, which is linked with the ZDHC CMS-TIG Chemical Management System Technical Industry Guide. So basically, this will help you to identify your knowledge gaps in terms of the CMS, and it will support you for self-improvement, self-improvisation as well. And also, after implementing this Supplier to Zero, this will definitely help you for improving your HIG FEM scoring as well. So in which there are 3 levels. As of now, only level 1 and level 2 is active. Level 1 is all about the self-assessment. So a facility, they need to self-assess their chemical management systems and then evaluate it, and then complete the assessment. Level 2 is all about your the confirmation for the implementation. So whatever you are doing, you need to upload a document. You need to upload a documentary proof you need to upload, and those documents will be reviewed by the ZDHC team. And once you are you meet all the requirements, then you will get a level 2 certification as well. This is how it looks like. The validity of the certificate is for the period of 1 year, and this certificate will also reflect into the ZDHC gateway account. The third part is about the output chemical management, where you need to perform a testing with respect to ZDHC wastewater guidelines and generate the clear stream report. The clear stream report will help you to understand your non-conformities in a very easy to read, in a non-technical format. We have, from this year onwards, we have given the scoring methodology. So this scoring methodology will help the brand to compare the wastewater or output chemical management performance between their entire supply chain. So this is how the scoring methodology will work. Please understand that the wastewater testing is not a pass or fail report, but it is a tool to support you for improving your input chemical management as well as the process chemical management part as well. And then lastly, we have a platform called as a ZDHC Academy, through which once again, I request all of you to please mute yourself. And then, and then we have a platform called as a ZDHC Academy, through which the suppliers, they can register themselves and they can take the trainings as well. All the courses are registered here under the courses list. ZDHC accredited training providers, they can take all these courses, and for getting a certificate, you must achieve more than 80% of scoring as well. And lastly, we have a resource-based platform called as a knowledge base, ZDHC knowledge base. So on our website, roadmap20.com, there is an option of resources, and under resources, there is an option of ZDHC knowledge base. So you can visit this ZDHC knowledge base for any kind of your questions. So whatever questions you have regarding ZDHC, you will get the answers here. So the entire page is divided into these 8 different chapters, and you will get if you have any questions related to gateway or academy or anything, you just visit that chapter and you will find the frequently asked questions. Otherwise, you can write your question here, search for articles, and you will get similar kind of results. Even if you think you haven't got the answer, then you can write an email to our customer support team at support@zdhc.org, and they will get back to you with the answer. So if still you are not registered into the ZDHC ecosystem, then I request all of you to register into ZDHC Gateway platform, so that you can find out the safer alternatives for your products, as well as you will get all the information related to the entire ZDHC Roadmap to Zero program. And once again, I would like to thank Steffi and Manuel as well for organizing this InConnect session. If you have any question, please let me know.
Thank you. Thanks, Sakit. I think we have one question in the chat asking whether we're allowed to share the presentation file, or can you direct them to somewhere on the website or a portal where they can access all the information you just spoke about?
Yeah, I will share it with you, and then you can share with the participants.
Okay, great.
Okay. Any other question?
If you have any other questions about the program or the platform or the gateway, please feel free to write it in the chat. We have some time also at the very end to ask Sakit any other questions. Otherwise, we can hand it over to Manuel.
Hi, hello everyone, and thank you for being here today. My name is Manuel Romero from PantaRei. As Steffi mentioned, we'll be talking about the water and wastewater treatment. So I will start sharing my screen here so that we can dive into the presentation. Just let me know once you are able to, all of you are able to see my screen.
We can see it now too.
Okay, you can see it now, right?
Yep.
Okay, so basically, today's session will deal also with achieving the ZDHC standards with PantaRei's innovative wastewater solutions. So just a little bit about us, in case you don't know us. Well, we are an Italian company with international presence, and we've been in this market for 17 years. We are trying to help our customers achieve their environmental compliance related to water and wastewater. We have 17 years of experience as PantaRei, but some of us, such as PantaRei's founder, Mr. Felice Raca, has more than 25 years of experience in this water and wastewater treatment field. We have more than 150 effluent treatment plants, and more than 100 are located in Southeast Asia. We have a consolidated relationship with our customers, and this wouldn't be possible without our local representatives, like Primatec in this case in Indonesia, of course. And we can offer anything that goes from borehole or well water treatment to water recovery, and of course, secondary biological treatments. We think that one of the most important things about us is that we focused on the textile industry, because we know it's a very specific kind of effluent that you can have in the textile industry. And this is why we strive to give the most sustainable solutions for this kind of market. We're an ISO certified company, but most importantly, and we're proud to be an accredited training provider of ZDHC. As Saket said, this is not a certification, right? This is a program that has united partners and contributors with the common goal of guaranteed water discharge with increasingly stringent parameters as a part of the compromise with environmental sustainability. We want to contribute as much as we can with this shared objective, because as we like to think about it, ZDHC is not a certification, is not a law requirement, it's a philosophy of having a holistic approach from cradle to grave, a closed loop, right? Because if you have good inputs, you will have good outputs. And this is what we're trying to do here, like to put all the stakeholders together for a greater good. And then we'll come to the ZDHC wastewater guidelines. Many of you may already know this document. This is in order to have a single approach towards this discharge limits in the textile industry. Because now we know that in different countries, there may be different regulations, that this document with the technical team and also with the buyers stakeholders, what it's trying to do is to create an even baseline for everyone, so it is clear for everyone, and that this guideline is your go-to reference point in order to know what to do when it comes to wastewater, so that everyone can have the same documents, the same approach. Of course, in each country, you must comply with the local regulations, but we're trying to do here something that is that goes beyond that allows you to be, let's say, compliant not only with local regulations, but also with the buyer's requirements, because the buyer requirements ultimately are dictated by the end users, right? So nowadays, we all want to have cleaner materials, cleaner water, and cleaner supply chain overall. And through these wastewater guidelines, we look at the output part. But as I said, the MRSL is a very important guideline as well, because basically you get what you put into the system. Just to go a little bit into the technical part of it, these are the conventional parameters of the wastewater guidelines. These are some of the most common values that you may look at and that you may know already, such as the pH. You can see that it's from 6 to 9 is the limit. The temperature differences, in order to have 3 different columns that are the wastewater foundational guidelines. These are the values that you are expected to respect, that are requested, that are expected from everyone, from every factory, right? Then you have the wastewater progressive guidelines, which are one step ahead. They're looking to more stringent limits to have cleaner water discharges. And then finally, you have the aspirational guidelines, which are meant to be for the best in class, for the best approach that you can have with your wastewater treatment in order to have the cleanest possible discharge that, in fact, as per the parameters that you will see, it's not even discharge water because you can basically reuse it, right? As you can see, for example, the color 753 is foundational, 211 is aspirational. That's very clear water. That's measured in meters -1. And then you have the foam. You have here some other parameters that are also part of the conventional side. For example, the ammonium nitrogen, the AOX, biochemical oxygen demand, and chemical oxygen demand, which are probably the most famous, you can say, parameters when it comes to wastewater quality. That doesn't necessarily mean that they are the most important, but they are some of the base parameters that are used worldwide, right? So you can see that regarding the chemical oxygen demand, to be compliant with the foundational guidelines, you need to achieve, for the textile sector, 150 milligrams per liter. But if you want to be aspirational, you need to go to 40. And we'll get into how you reach that part just in a second. We will also have parameters like oil and greases and so on and so forth. And there are some parameters that are not currently regulated, but that are needed to that you need to report in order to see the holistic performance of your wastewater treatment plant. For example, like the total dissolved solids. This is a parameter that is important because it tells you basically how much salt you are using in your process. So if you're doing cotton dyeing with sodium chloride with lower salt, for example, you will have higher values than if you are doing polyester or if you are doing just washings or rinses. Then, how to meet the wastewater guidelines parameters? Well, I think that some of the most important things come from simple approaches. First one, know your wastewater. It's important to carry out composite samples. It's highly recommended that not only conventional parameters are tested, but also heavy metals, for example, in order to know that you are compliant with the complete wastewater guidelines. What we saw before is an extra for the conventional parameters, but of course then you have metals and you have so many other components. And you have, of course, the MRSL as input, because here we're talking about output, but as we said before, what you give is what you get, basically, also in wastewater treatment. So first of all, you need to know what kind of wastewater you have. And then, depending on that, you can choose the kind of treatment technology that will better suit your needs. There can be a whole range, a very wide range of technologies that you can apply. They will depend on what kind of water quality you have, and they will depend on also how much space you have to install that kind of treatment. For example, a conventional biological treatment is, in many cases, it's a preferred solution because it has lower operating costs and low sludge generation. You can have also a membrane bioreactor and a moving bed biological reactor, or in some cases even an anaerobic reactor. It depends on, of course, the type of wastewater that you have. All of these are biological parameters, biological treatments, but each of them has specific requirements and specific characteristics. After you have chosen the technology, depending on the space you have, the wastewater that you have, it's always a good idea to think that regulations, as we said, can be dynamic, because also the wastewater guidelines are dynamic, because the type of textile production that we have today is not the same kind of textile production that we had 20 years ago. So likewise, the regulations should be adapted to the current times, to the current types of production facilities that we have. So we should also, it would be a good idea to keep in mind that in future, some things may change, of course, and to have available space for future developments. Or even because maybe now you have a very good wastewater discharge, but in the future you want to recover, to recycle some water, so you will need, of course, some space to do so. So about the wastewater treatment technologies, the basic unit, the first step towards sustainable development and environmental compliance is the implementation of a good technology when it comes to wastewater treatment. For example, we mentioned the biological process. Why we mention the biological process and not only chemical physical processes? Well, normally we're trying to keep it, let's say, as also as natural, let's say, as possible, right? So to generate the lowest possible amount of chemical sludge. When we do a chemical treatment, chemical precipitation, sometimes we have a very good performance in terms of solids and color removal, but of course you have an input which are the chemicals. So we're trying to clean the water with the lowest possible sludge generation here. And this is why we always try to make a balance, like what's the cost of the implementation, what's the cost of operation, and what are the benefits that you get from that. With the biological process, with the biological oxidation process, ultimately, what we're trying to do is to break the molecules, the pollutant molecules, in order to have carbon dioxide and water. So the simplest molecules that we can get from the complex carbon sources that we get into the discharge. And after we have stabilized, after we have removed this biological matter, this organic matter, then we can think about tertiary treatments for water recovery. Here we have some examples of pretreatments, because the biological system or any kind of wastewater treatment will have pretreatments, primary treatments, secondary treatments, and tertiary treatments. As pretreatments or primary treatments, what we can have here is screening to remove the largest particles, to prevent them to going forward to other processes or to the pumps or from settling on the tanks and reducing the available volume. Then we have the fibers removal, because sometimes you can have, for example, when you do cotton dyeing or you have production of sweaters or hoodies or so on and so forth, you have a lot of fibers sometimes. And if you let those fibers pass through the subsequent treatment phases, what will happen is that you will have a higher organic load, you have higher suspended solids, and ultimately more sludge generation. So we're trying to remove these fibers and to have them become, instead of a waste, a resource. How do we do that? Basically, we have customers that have biomass boilers and biomass, they heat up and they burn these fibers to generate more energy. So from waste, we go to resource when it comes to fibers removal. Then we have the neutralization, because normally, as you may know, when we have in the textile factories, especially when we do cotton dyeing, for example, we have the consumption of soda. So the pH will be high, will be alkaline. So we need to neutralize that, to lower it in order to keep it closer to neutrality, to a neutral pH. That doesn't necessarily mean that we need to have pH 7. It can be a little bit alkaline because you will need a little bit of alkalinity in the biological process, but it needs to be somewhat neutral. Then after, another important thing about the wastewater treatment is the homogenization. We need to make sure, especially for biological processes, that the wastewater going into the biological treatment has a constant characteristics and constant flow. Why? Because this is the food that we're giving to the microorganisms that die in the biological tank. So we say we need to keep a constant food supply to them, because we cannot give them a huge amount of food for 1 hour and then no food for 4 hours, because then they will at some point die, or they will, only some species will be present, the predominant species. So we want this to be as varied as possible. We want it to be as constant as possible in terms of discharge. A constant input in terms of wastewater quality will give you also a constant output in terms of waste quality and ETP performance. We also have the cooling section here because it's important to keep the water temperature for a proper biological treatment. Let's say around 35, 38 degrees, something like this. But definitely it should not be a very high temperature because we know that textile discharges sometimes can have very high temperatures. So we cannot work like that for the biological process, but also for some machines that many, even submersible pumps and so on, cannot work for, let's say, with 60 degrees temperatures constantly. So this is why also cooling will be necessary. As secondary treatments, we have the normal biological treatments with activated sludge, the conventional activated sludge. We can have the membrane bioreactor. We will talk more about that in a minute. And then we can have the moving bed biological reactor, which is a biological treatment too. But here, in this case, the biomass is attached to these plastic supports in order to develop also more amount of biomass growth around the supports that have a huge active area inside because of the pores that are inside. After we have treated the wastewater, we have to think also about the sludge, right? Because that's another important part of the process. And the sludge is also part of the, is also regulated, not only by local regulations, but also by the ZHC guidelines as well. First of all, we normally need to do a thickening of the sludge, and then we can think about the sludge dewatering. It can be a filter press, it can be a screw press, it can be a belt press, or it can be a sludge drying beds. Also, depending on the amount of sludge generation that you have on a daily basis. Another part that is important after we have treated the water with secondary treatments is the possibility to recycle that water. Once we go out of a biological treatment, what we need to do is to refine, to purify the water to a higher level so that it can be reused at some point in the factory. Normally, it can be filtered. Then we can go to an ultrafiltration section to further remove the suspended solids and also the colloids. And also the apparent color, because the true color will stay there in solution, but the apparent color will be removed as you remove the turbidity, right? So that's the application for ultrafiltration. And finally, if we want some water that is completely free of color, that has a very low salt content, and that has low hardness and can be reused even in the dyeing process, then we need to talk about reverse osmosis, which is the final treatment, let's say, for the water. And water coming outside of reverse osmosis will definitely comply with the aspirational guidelines of ZDHC. So a little bit more about the MBR application, which is this membrane bioreactor, is that this is still a biological treatment. This is a treatment that has suspended biomass as well, like the conventional one, but we have one limitation. What is it? That at some point, if you keep increasing the mixed liquid suspended solids, you will have a very high solids load in the secondary clarifier, and you will ultimately have a sludge washout, right? So what happens if we don't have a secondary clarifier? If we have a physical barrier that can withhold the sludge, but that can let water pass, well, that would be the membrane bioreactor. With the membrane bioreactor, you can increase the MLSS concentration without the sludge washout risk, because there is a physical barrier. When we increase the MLSS concentration, what happens is that the space that you need for the water treatment plant is lower. You need less space. Why? Because what we always say here, let's think about the ETP, the wastewater treatment plant, as a factory where you clean the water. The MLSS will be the workers. If you have a factory with 100 workers, there is so much fabric that you will be able to process. But if in the same factory you have 200 workers, you will be able to double the production capacity. The same applies to the machines. If you have the twice as much machines, then you will be able to produce more. The same with the MBR, because you will have more workers, which are the biomass inside the biological reactor. And this is why you can see it two ways. That within the same volume, since we have more microorganisms, you can treat more wastewater, or you can treat the same wastewater within the same space with a shorter residence time. Also, the MBR membranes are basically an ultrafiltration section. That means that after them, you normally have COD less than 80, DD less than 10, TSS less than 3. And for these specific conventional parameters, you will be in the progressive area of the ZDHC wastewater guidelines. Here you can see some examples of MBR cassettes. You can see we're trying to provide compact cassettes so that you can plug them inside the tanks. Here you can see that the water can pass and flow through the membrane sheets so that it can be collected as permeate and extracted from the system without clogging the membrane modules. These are some applications. Here you can see the cassettes which are submerged, but before the cassettes, you can see the biological oxidation tanks with the diffusers in this rendering. Just generally speaking, here you have the biological oxidation. You feed the MBR tanks. The water is collected by the permeate pumps, is extracted in these collection pipes, and then the rest is recycled back into the biological system. We have some more pictures here. Sometimes you can even make them with a very low visual impact, right? Like here, in some cases, some customers would plant trees and put the garden, and then you have the MBR tanks which are submerged. So from the visual point of view, this will look also very good because you will have them integrated into a more environmentally friendly general context. More examples, you can put them like underground as well. And then after we have treated the wastewater, we can talk about the water recovery. After we have stabilized the organic matter, we can go through a series of steps like fine filtration, ultrafiltration, reverse osmosis. However, if you have already an MBR technology before the reverse osmosis and in the biological oxidation tank, you do not need to filter and ultrafilter the water because since the MBR, as we said itself, it's an ultrafiltration section, you can directly feed the MBR output into the reverse osmosis, thus saving additional space in the system. The reverse osmosis, as we said, is the ultimate filtration treatment because it's the only one able to separate all kind of dissolved salts. Normally, the permeate will have very low TDS, lower than 150 milligrams per liter, no color and very little hardness or no hardness. And you can reuse this in the production units. And of course, when you have this kind of water after a treatment, you will be compliant even with the most stringent guidelines, which are the aspirational guidelines of the ZDHC program. This is just an example of how a pre-assembled reverse osmosis kit would look like. And this is some real values that we got from some facilities, textile facilities, of course. These are the average values that you would expect and they had after the biological treatment because they were pretty much compliant with the conventional guidelines. So their average was 30 BD and 150 COD. This doesn't mean that they were constant parameters, of course, because there was some fluctuation. Sometimes it was going to 140, 120, 153, let's say. The average is more or less around this. And the water that was obtained after the water recovery section with reverse osmosis was like this. BOD less than 3. Actually, that was the measuring limit, so it might have been 0. COD less than 30. TDS less than 100. Hardness less than 1 milligrams per liter. Chlorides less than 20, and sulfate less than 5. And you can see, and also the color value was less than 5 units of platinum cobalt because the water was transparent. So this water can pretty much be reused and was actually reused into the dyeing factory. Here we have some pictures also of this study. In this case, we had like biological treatment, ultrafiltration, and reverse osmosis. These were the results. After biological treatment, the wastewater looked like this because no decolorant agent was used. So of course there is color there. After the ultrafiltration system, the same water looks much clearer. Why? Because the ultrafiltration removed the colloids and suspended solids, therefore removed the turbidity of the wastewater. So apparently the wastewater color was like this, but if you ultrafilter that water, then it would look like this, much cleaner, of course. And after the reverse osmosis, you can see that the water was completely transparent with that value of less than 5 units of platinum cobalt. So this is basically, in a nutshell, what the wastewater treatment, the ATPs for the textile industry would look like, and the options that you would have. Then we have a case study in order to talk about a little bit about the root cause analysis, the corrective action plan, and the solutions that were found. This is one example of an aeration basis and biological oxidation tanks that were in which some processes were developed to enhance the performance and also the energy consumption. The case that we found, the initial conditions were that this factory had an incoming flow of 9,000 cubic meters per day. They had a theoretical oxygen requirement of 737 kilograms per hour of oxygen. They were doing the aeration with surface aerators, with 28 machines of those. Each aerator capacity was 27.5 kilograms of oxygen per hour. That's the theoretical capacity. The unit power was 22 kilowatts, and the total installed power was 616 kilowatts. So a very significant amount of energy installed power. But the absorbed power was also very high, 493 kilowatts. And the energy consumption on a daily basis was 11,832 kilowatt hours. This means that they had 1.31 kilowatt hours per cubic meter as specific energy consumption, which is a very large value considering that this was only for the aeration section. So we say, okay, there is an issue here with energy consumption part, right? So we need to know, where is it coming from? What is my root cause analysis? I need to identify the source of this high energy consumption. Why other biological treatment plants have a much lower energy consumption, and why do they have a very high energy consumption? Well, we saw that, of course, the most evident thing was that they were using surface aerators. This is one kind of aeration technology that has been used for decades worldwide. They are sometimes called the first generation of aeration systems. There is a high energy input in order to try to mix the water and to have that water go inside the tank again, rich of oxygen. Okay, well, in theory is okay, but then you can see that there are gradients of the sulfur oxygen concentration in the system, and those gradients can be very significant, as you can see. On top, we can have 6 milligrams per liter, 4 milligrams per liter, but then that concentration keeps decreasing until basically we have almost no dissolved oxygen in some areas that start becoming anoxic areas. And at some point that can create also some smell issues in the plant. So we identified what for us was the source of this energy inefficiency. So we said we need to focus on that and to have a more efficient and more homogeneous air distribution in the system. In this case, we consider fine bubble diffuser because each fine bubble diffuser had 7,000 microholes. So 7,000 micro bubbles were being generated in each single diffuser. Since you have more exchange area for the transfer between air and water, then you have a higher transference, because the mass transference is regulated by the concentration gradient, but then you multiply also by the surface area, right? So more area, more mass transfer, more oxygen transfer efficiency. What happened after this was implemented? Well, there was a significant change. The oxygen requirement, theoretical oxygen requirement was the same, but instead of surface aerators, we put the oxidation grid like the ones you can see here, and the diffusers were fed through blowers. So we considered, instead of those 28 surface aerators, we considered 4 blowers and a diffuser grid. We were supplying 8,000 cubic meters per hour of air. Each blower had was supplying 2,000 cubic meters per hour with an installed power of 75 kilowatt, and in total we were absorbing 193 kilowatts. So the energy consumption dropped from 11,800 to 4,632 kilowatts, meaning a specific energy consumption. We're talking only for the biological process as well, for the biological variation. Of course, you have the power from the pumps and other appliances, but the largest amount of power you're consuming comes from the biological variation. So we decreased from 131 to 0.51 kilowatt hour per cubic meter. That means 61% energy consumption reduction just by changing the aeration technology. You can say, of course, yes, an investment was made because the technology was changed. So for sure, there was an investment. But as you can see, the advantages from that investment were huge, were really significant. So in this case, the corrective action plan was the modification of the aeration technology within the effluent treatment plant in order to achieve a higher efficiency. Sometimes when you implement this kind of upgrades, you also get some side effects that can be positive. For example, they have been struggling a little bit with some parameters, especially with suspended solids. And some anoxic zones got created when there was a little bit of sludge washout. And COD and BOD values were increased as a consequence. When the aeration was more homogeneous, not only we decreased the amount of energy that we're using, but we also improved the performance of the effluent treatment plant by doing this modification. Because as we see, everything is related. So you have focused on one of the main variables, act on that as part of the root cause analysis, but it's also very important whenever we do something like this to change one variable at a time to see the impact of that variable in the whole system. This is what we did, and these were the advantages that were obtained. As one of the last slides from our side that we would like to share is that there is not just one right approach to wastewater management. There can be many right answers. The important is proactive collaboration among all the stakeholders. That means between the factories, the buyers, the chemical formulators, the solution providers of wastewater treatment, and everyone who's involved in the supply chain, because we are all interconnected. And we want to reach an integrated and global solution as a team. That is what ZDHC is about. This is why we said that for us, ZDHC, most of all, is a philosophy, because we want to create synergy for sustainability. We also talked about our local presence in Indonesia. Our partner in Indonesia, PantaRei Group. So in case of Steph, if you want to jump in and say anything about you as a closing statement. Also from our side, you're more than welcome to do so. As we have been working with Primatic for a long time now, and this is about the implementation in Indonesia, right? In the Indonesian market for water and wastewater solutions. Now we're going to have, yes, Steph, if you want to say anything, you're more than welcome to do so.
Oh, no, actually, no, thank you for that. And yeah, just in case I'm sure there's some people here on the webinar that are from Indonesia, based in Indonesia. So if you have any questions specifically for the Indonesian market, then please feel free to also write them in the chat. Thank you.
Thank you very much. So I think that we can now have some questions and answers, right, for this part regarding the root cause analysis and of course the water and wastewater treatment.
Yeah, Manuel, I think we have one question a bit more general for you from Eva. She asked whether you can let us know the areas that PantaRei covers. So
Okay,
I'm assuming that are the countries.
Okay, let me get the okay. So yeah, PantaRei is present in most countries through local representatives as well. Of course, we have a very strong presence, as you can imagine, in Indonesia. We have very strong presence in Bangladesh, Pakistan, and in Southeast Asia, also in Sri Lanka, and also in Central America and the Americas in general. But we also have presence in Europe and also in Northern Africa. Those are the main areas where we are present. But if anyone here is located in an area that may not be covered directly by one of our representatives, you can always contact us directly in order to give you any answer or any solution that you may need for your wastewater treatment. You can always visit also our website. I will write it in the chat box, which was www.pantareiwater.com. There you can find a contact section, and you can also write to us directly. I will also write my email address here. And you can contact us anytime with any kind of request that you may have with water or wastewater treatment. And of course, also through ZDHC, because as we said, we're all partners here looking for a common goal when it comes to water and wastewater treatment, but not only, because as we said, this is a holistic approach. So also, if anyone in this webinar has any specific need regarding maybe chemical management or anything like this, Seket, of course, will be able to direct you to the to the person who has the most expertise, the most knowledge regarding each area in which you may need help for all the textile process. It can be input, as we said, chemical management, chemical formulators, chemical reporting, or maybe you just want to join the program, if you just want to join ZDHC, then of course Seket will guide you in the process for sure, as well as the other ZDHC colleagues. I don't know if you want to say anything, Seket, about this, or any recommendation that you may have.
Thank you very much, Manuel, for such an interesting presentation with all the technical details, and Steffi as well for organizing this session. If you have any questions further to this session as well, I will definitely share my slides with Steffi, so she can share with all of you. But if you have any questions, please let me know, or you can send us later on also, you can send us an email.
Yeah, great. So I think, Manuel, if I can share your slides as well, I can share both of your presentations and also your contact details with everyone that has attended the webinar. And if anyone has questions for us as well, please feel free to email us. We'd be happy to follow up. But yeah, we still have a bit of time. We're still finishing off early. So if you have any questions, feel free to write them in the chat box. Otherwise, you can send us an email. And also, I just wanted to mention before we wrap up, we would like to announce that part of this year's ZDHC Roadshow in Indonesia. Primatech, in collaboration with Testex and SGS, and of course ZDHC, will be hosting an in-person workshop in Bandung early July. So we will be sharing more details on this very soon. Yeah.
Yes, would love to see you in Bandung, in Indonesia, with this event. We're very excited to do so. There's going to be, of course, the three of us plus, as Steffi said, the additional partners like Testex that are going to be focused on this presentation with very specific information, especially country information, right, Steffi? So if that's your go-to place, if you want to get like your hands on ZDHC and some of the analysis, chemical formulators, wastewater treatment, or anything that you may need regarding the whole textile process, and especially ZDHC as a program, and you want to know, because we know that sometimes it's difficult maybe for you to know where to start, right? So I think that the roadshow would be the perfect place for you to start your journey along us with ZDHC.
Great. Okay. Thank you. So if no one has any questions, then thank you very much for being part of today's webinar, and a big thank you to our speakers as well, and hope to see you at the Bandung event early July.
Thank you.
Bye. Bye, everyone.
Thank you, everyone. Bye-bye.
Thank you.
Bye-bye. Thank you. Thank you.
Bye-bye. Thank you.
Very much. Yeah. Thank you, everyone. Bye-bye.
Bye.
Thank you. Thank you.